divided by x. Okay, we have another example here, and this time we have a definite integral. We have limits of integration. So to solve this one, first we just find the indefinite integral, we just find the antiderivative, and then we can evaluate the antiderivative at these limits. So first let's just find the indefinite integral. So to do that, we're going to have to use U-substitution. So in this case, it looks like we have an inside and an outside function because we have this square root guy, and then we have something inside of it. So let's let u equal what's inside of there. So we'll let u equal x squared plus 3. Now we need to find du, so we take the derivative on both sides with respect to x. So we get du dx equals the derivative of x squared plus 3, which is just 2x. Now we solve for du by multiplying both sides by dx. So we have du equals 2x times dx. Now let's look at our integral and see if we can make any substitution. So we see that we have this x and this dx. So that's what we can let u equal. And since our du equals 2 times x, not 2 times x times dx, not just x times dx, let's solve this equation right here for just x times dx, because that's what we have up here in our integral that we can replace with du. So solving this equation for just x times dx means we need to divide both sides by 2. So then we'll get du divided by 2 equals x dx. So now we can replace the x dx in our integration with the du over 2. Now let's rewrite this integration so we can clearly see what we're going to be plugging in, what our substitutions will be. And also it'd probably be good to replace the square root with a 1/2 power. So now we know that x squared plus 3, that's going to be the value of u, so we'll replace that with u. And then we know that x times dx, we just said that was equal to du divided by 2. So we'll make that substitution. So upon making those substitutions, we now have this integral, which we can write like this. And the way I did that was I just took the 5 and put it on the outside because it's a constant, and I took the 1/2 and put it on the outside because it's a constant. So that gives me 5/2 on the outside times the integral of u to the 1/2 power. Now when I take the integral of that using the power rule for integration, I just add 1 to the 1/2 power, so that gives me a 3/2 power, and then I also divide by that power. Now I just need to simplify this expression a little bit. Basically what I have is 5/2 divided by 3/2 times u to the 3/2 power plus c. So I just need to simplify this complex fraction. So of course I can simplify the complex fraction by skip, flip, multiply, or keep, change, flip, keep, change, flip, or skip, flip, multiply, whichever one you call it. So that's how I can calculate these complex fractions. So that will just be 5/2 times 2/3, which would just give me 5/3. Now I can substitute back in the value of u with respect to x. So I now replace the u with my x squared plus 3. And so I get this as my indefinite integral. But that was just the answer to the indefinite integral. The question we're originally asked is find this definite integral with limits of integration. So now I need to plug those limits in to my antiderivative. So to solve this definite integral, I first want to find this antiderivative, which is what I just did. So let's plug that antiderivative in. So I plugged in the antiderivative, which I just found. Now remember when we're doing definite integrals, we can just let c equal 0. So we don't really need that part. Because remember, with definite integrals, we don't really need the c because we saw it works out the same either way. Okay, so now we have this. Now we plug in our limits of integration into our antiderivative. And now they want us to round the answer to the nearest thousands. So we can just plug these numbers into our calculator, 4 to the 3/2 power and 3 to the 3/2 power. and then round our answer to the nearest thousandth. And so we get approximately 4.673. So that will be our final answer for this definite integral. So when you're solving definite integrals, first you need to find the indefinite integral, which in this case we had to use U-substitution to find it. And so then once you find that, that's your antiderivative, and then you just evaluate the antiderivative at the limits of integration. So it works just like we saw before when we studied definite integrals. It's just to find the antiderivative, we had to use something new.